Okay, so continuing our limit discussion here, we're going to look at the limit existence theorem, and so making sure that our limits exist. So sometimes we would have something where the limit doesn't exist because it just doesn't make sense. So the limit existence theorem says that the limit as x approaches a of f of x exists if and only if the limit as x approaches a from the right of f of x is equal to the limit as x approaches a from the right of f of x, which is equal to b, where b is any real number. So remember that infinity is not a real number. So if we have the limit as x approaches, or you're fixing to see, as x approaches some number from the left and from the right, and they both approach infinity, that doesn't exist because b has to be a real number. Okay, so let's look here. That's what this first one is talking about. So as x approaches 2 from the left, that's what that negative sign means, remember. So you can see as it approaches 2 from the left, it is getting steeper and steeper and steeper up. It's going up to infinity. And then as it approaches it from the right, it's going to go up to infinity as well. What is f of 2? F of 2 is undefined. Remember that, because there's a vertical asymptote there. Okay, and then does the limit of f of as x approaches 2 of f of x exist? Why or why not? It does not exist because, well, we just talked about that. Infinity is not in the real number system. So that double R means the real number system. So the set of real numbers, I should say. Okay, so let's look at example 2 because this is a very, very interesting example here. So we're going to look at the limit as x approaches 2 from the left. So as x approaches 2 from the left, it looks like it's approaching y equals 2. Okay, so it looks like it's approaching 2, and it is approaching 2. Okay, because these numbers are getting closer and closer and closer to 2. Then as x approaches 2 from the right, okay, then it's also approaching that same y value, which is 2, okay? But what is f of 2? So f of 2 is all the way down here at -3. So does the limit as x approaches 2, does it exist or not? So it does exist, okay? Yes, it does exist, okay? Because by definition, if the limit as it approaches from the left and the limit as it approaches from the right, if that's the same number and it's a real number, then it does exist. So I'm going to say since. So because of the way AP is set up, you need to get used to writing your thought process. Like they don't necessarily want to know that you just know math. They want you to know the why behind it and make sure you know kind of sort of all of these theorems, so to speak. So I just want to make sure that you start to kind of get that in your head. So we're going to be doing lots of that in class. All right, so example 3. So as x approaches 2 from the left, it looks like it is approaching 3 of f of x. And as x approaches 2 from the right, it's going to be approaching -3. And then but what is f of 2? F of 2 is going to be 3. And so does the limit as x approaches 2 exist or not? So since these two numbers are not equal, okay, they won't exist. This does not exist. So D&E means does not exist. Okay, so it's defined at 2, and they both approach a certain number. It's just not the same number, so therefore they don't exist. So based on what you've seen so far, does f of a have to be defined in order for the limit as x approaches a of f of x to exist? It says, draw and explain 2 different graphs to justify your reasoning. In both graphs, f of a should be undefined in one graph, and the limit should exist, while in the second one it should not exist. So here we go. Let's look at these 2 graphs here. So if we have a graph, kind of like the one that we saw a little while ago, like in the first example last lesson, where it just had that hole. So if I have a number, and it's coming up right here, it goes up, and this is at a, whatever a happens to be, then f of a is undefined. So on this one, f of a is undefined, but the limit as x approaches a of f of x does exist. Okay, because it's approaching the same number. Even though we have a hole there, it's still approaching the same number, and that's what we're trying to get at. Now, if you have some sort of jump, so if we were to have something like this, let's see here, if I can draw this. So let's say we have like, and then you have a hole here, and we have a hole here, and maybe it goes down like this. Okay, so it kind of jumps like that. A is not f of a is undefined, and the limit as x approaches a of f of x does not exist because of that big jump. They're not approaching the same number. Okay, it's like, okay, doesn't work. When they approach the same number, works. Even though there's a hole there, that's perfectly fine. All right, so now let's look at some tables. Okay, so we're just going to kind of evaluate these tables and look at the limits here. So as a limit as x approaches negative infinity, so as these numbers get larger and larger and larger, it looks like it's not really approaching any number. So it looks like this is going to keep going and getting bigger and bigger and bigger, especially once you see those big jumps like that, like from 3 to 9, 9 to 33, and then 33 to 513. That's a big jump for just a short amount of, for a small, I'll say, change in change in x. So then the limit as x approaches negative 3 is just going to be this number right here. Okay, because there's nothing to tell us that it's going to have any kind of hole or jump or anything like that. And then the limit as x approaches 1 is going to be here at 1.5. And then as x approaches positive infinity. So what do you notice as these numbers start getting larger and larger and larger? They start approaching a certain number, and that number is 1. Okay. So just looking at these tables and be able to kind of picture the graph a little bit based on these numbers and determine those end behaviors. All right, so this one you can see we do have a couple of holes here at -1 and at +2. So we'll take a look here. So as x approaches negative infinity, so as these numbers get way larger, what do you notice? It looks like it's approaching +1 because at -1,000 it's 1.001. So the larger and larger and larger you get, closer and closer to 1 it's going to be. The limit as x approaches -1 from the left. So I want to look at these numbers right here. Okay, so this number is a very, very large number, 2,000. So I would say as it approaches from the left, you're going to have positive infinity. It's going to be very, very large. Remember, we kind of talked about this. You're probably not going to have a limit of a number that's going to be a gigantic number. Okay, I'm not going to say it never happens, but very rarely would you have that. And then, and you definitely wouldn't have it probably given from a table. It would probably be on some sort of graph, but I could be wrong. That can happen, but I'm just saying likelihood of it approaching 2,000 right there, or 2,300 is not likely. And then as x approaches -1 from the positive side, so coming in from numbers coming in from the right, so let's go from this way. These numbers are getting larger and larger, so this is going to be in the negative direction. That's going to be negative infinity. Then as the graph approaches 2, so f of 2 is undefined, okay, right here. That's what that says. But as they approach, you can see that they are approaching what looks to be like 0.333 repeating, which would be 1/3. And then as x approaches infinity, so as these numbers get really large, notice that these numbers are getting really close to a +1 as well. So we'd have that horizontal asymptote. And then as x approaches -1, which we looked at, that is going to be does not exist. And so let's talk about why. Remember, these two numbers are not equal. That's the first thing you have to look for. And if they are equal, it has to be a real number. Well, we talked about infinity not being a real number, so you can't have those there. Okay, so now we're going to look at this kind of as a graph, so you can see some jumps again. And so let's look here. So as x approaches -3 from the left, it is going to be approaching positive infinity. This is getting larger and larger right here. It's going to keep going up and up. So then as x approaches -5, let's do, from the -5. As x approaches -5 right here, we have a little hole here, which a hole is okay, remember, as long as it continues on. And so it looks like they're both approaching 4 right there. And then we have the limit as x approaches -1. -1, which is right here. Let's see. So right here, -1, which is going to be at y equals -1. So that's kind of odd. Not odd, but just different. All right, and then the limit as x approaches -3. Okay, so here you'll notice that as x approaches -3 from the left, we get positive infinity. But when it approaches it from the right, you're going to have negative infinity. So that's no good, okay? They're not real. Those aren't real numbers, and they're not equal. So no bueno. So then this is going to be D and E. This does not exist. As x approaches 2 from the right, 2 from the right is going to approach this number here, which is 6. Oops, sorry, I skipped one. And then as it approaches 2 from the left, it's going to approach 1. Oops, wrong one. There's so many over here. I'm not going in order. So, and then as a limit as x approaches 2, so since these two numbers are not the same, then this is D and E. This does not exist. Okay, so remember that jump. No good. And then they got a high five. Yeah, so like when you high five, it's like, it doesn't work. It's kind of like limit. You want to make sure they high five. Even if you like miss, like right here with the hole, that's okay. It's just gonna get there. But if you like miss altogether, it's a bad deal. So as x approaches negative infinity, this number is going to get closer and closer and closer to this y value, which is 2. And then as it approaches positive infinity, then it's just going to keep going up and up and up to positive infinity since it's moving upwards. So this is, I've seen lots of, I say lots. I think that this is a question that can be on the AP exam. So some limit questions that are like this. I've seen a lot that are graphical like this that are piecewise. So you're going to make sure you're paying attention to which side you're coming from, first of all. And second of all, make sure that they're equal. They have to high five. And if they stop right there, really, really close, they don't make it, that's okay. As long as they don't, they don't miss each other. Okay, they gotta get together. All right. So that is, limits, looking at that through with a graph and the table. So it's kind of sort of what you got on your practice, and still looking at limits as as x approaches a certain number, and we're fixing to get to where we don't have graphs and tables anymore. We're gonna actually have functions, and we're gonna have to do some nice little manipulation to them to be able to find that limit that way. And that's it.